Hello everyone, welcome to Soil Mechanics online course. Today I'm gonna talk about soil compaction. In many construction projects, such as highway, airport, and earth dam, it is required man-placed soils, or called fields, to build the foundation. Soils transported from bottom pit must be compacted so that they can support the upper structures. Soil compaction may be the least expensive method of improving soils. Since ancient times, people have already known how to use compacted soil to build dams and foundations for structures. For example, about 2,000 years ago, Chinese people already mastered the technique of soil compaction that was used in construction of the Great Wall. Many well-preserved ancient buildings in China were constructed upon compacted soils. Compaction is the densification of soil by removal of air in the soil mass. It is normally achieved by using mechanical compactors, rollers, and rammers with additional help of water. Compaction has many benefits. For example, it can increase the shear strength of soil and at the same time reduce soil's permeability, compressibility, and liquefaction potential. The compaction degree of a soil is measured in terms of its joint unit weight, gamma D. That is the mass of solids per unit volume of soil. From previous section, we know that the joint unit weight can be expressed in many ways as presented in these slides. The rightmost term was obtained by replacing E by E equals to W times GS over S, in which E is void ratio, W is water content, GS is specific gravity, gamma W is unit weight of water, and capital S is degree of saturation. From equation 1, we know that in order to increase joint unit weight, we need to reduce void ratio. That is, W over capital S must be reduced since GS is constant. For a given water content, the theoretical maximum joint unit weight is obtained when no air is in the void spaces. That is, when the degree of saturation equals 100%. Hence, the maximum joint unit weight at a given water content with zero air wounds can be obtained by substituting S equals to 1 into equation 1. So we can have the zero air void unit weight as expressed in equation 4. The lab test used to obtain the maximum joint unit weight of compaction and the optimum water content is called the Proctor test. Depending on the energy delivered to the compacted soil samples, Proctor test can be classified as standard and modified Proctor tests. 4 or more tests are conducted on the soil using different water contents. The results are plotted as joint unit weight versus water content. For fine-grained soil, for example, clay, the compaction curve is usually bell-shaped. From the bell-shaped compaction curve, we can have a maximum joint unit weight. The water content at which the maximum joint unit weight is achieved is called the optimum water content. You should also keep in mind no part of the compaction curve can lie to the right of the zero air void curve. Look at the bell-shaped compaction curve for fine-grained soil. You may ask, why there is a peak? Well, when water is added to the soil during compaction, it acts as a softening agent on the soil particles. The soil particles slip over each other and move into a densely packed position. Therefore, the joint unit weight after compaction first increases as the water content increases, and a maximum joy unit weight will eventually reach at an optimal water content. Beyond the optimum water content, any increase in the water content tends to reduce the joy unit weight. This is because the water takes up the spaces that would have been occupied by the solid particles. Compaction curve for sand is presented in this slide. For coarse-grained soils, the joy unit weight has a general tendency first to decrease with increasing water content and then increase to a maximum value with further increase of water content. The initial decrease of joy unit weight with increase of water content is due to the capillary tension effect. At lower water contents, the capillary tension in the pore water inhibits the soil particles to move around and be compacted densely. If the compaction effort per unit volume of soil is changed, the compaction curve also changes. As presented in this figure, with increase of compaction effort, the maximum joy unit weight of compacted soil is also increased. As the compaction effort is increased, the optimal water content is decreased to some extent. The parameter used to check the quality of compaction in the field is called degree of compaction, DC, which is defined as the ratio of measured joy unit weight in the field to the maximum joy unit weight determined in the lab by the Proctor tests. The typical required values of DC range from 90% to 98%, depending on the specifications. That is all for today. Thank you for your attention. See you next time.